Hey guys, welcome back. My name is Miss Danielson, and today we're doing another lesson on rounding. Rounding sensibly today, which this picture is not a very good example of. As you can see, this father and son seem to be having a lot of fun, but this does not look safe at all. Today we're going to learn how to round safely. As you know, every time we round, we make a small inaccuracy or rounding error, as we call it. That doesn't mean we've rounded incorrectly, it just means that our answer is not exact. Sometimes this can actually be dangerous. For example, the number of people in an elevator must not exceed 8 people. If someone wanted to make a safety sign for this elevator, they could say, rounding to the nearest 10, the maximum number of people in this elevator could be 10 people, because 8 does round up to 10. However, would that be safe? Bam! Now, I hope that doesn't actually happen, but 10 is more than the maximum of 8 people. So although that was correctly rounded, it was not safely rounded. Really, to the nearest 10, safely, we could say is the maximum capacity is 0 people. So in this case, we probably shouldn't round at all. The maximum safe capacity is 8 people. Let's try another example, and I'm really showing my age with this one. But way back in the 90s, there was a movie called Speed with Keanu Reeves in it, and it was about a bus that had a bomb on it that would explode if the bus's speed dropped below 50 miles per hour. Now, the interesting thing about this is that I am not American, despite my accent. I'm Canadian. Suppose a Canadian was driving this bus, where the American terrorist made this threat. 50 miles is approximately 80.4672 kilometers. Is this bus safe if the Canadian driver rounds this to the nearest whole number of kilometers? What would 80.4672 be rounded to the nearest whole kilometer? That would be 80 kilometers, right? Because 4 is less than 5. It's not big enough to round up to 81. But would that be safe if the bus's speed dropped to exactly 80 kilometers per hour? Bam! No, it wouldn't, because 80 kilometers per hour is less than 50 miles per hour. It's less than 80.4672 kilometers per hour, so the bus would explode. So, safely to the nearest whole number of kilometers, this Canadian driver should keep the bus at least 81 kilometers per hour. What place value could she safely round to? We could safely round to the 10th position, because 80.5 is above 80.4672. We are keeping the speed above the minimum, so it's still safe. Let's try one last example to make sure that really makes sense. So a bridge can support a maximum mass of 14.94 tons. Just to be absolutely clear, mass is the heaviness of an object. Round this value safely to the nearest 10 tons, whole number of tons, and tenth of a ton. So we're going to round this value in 3 different ways. And we're not just thinking about how to correctly round, we're also thinking about the situation we're in and what values would be safe and which would not be safe. So to the nearest 10 tons, 14.94 has got a 1 in the tens position and a 4 to the right of that. A 4 is not big enough to round that 1 up, so that's going to stay 10 tons. Would 10 tons still be safe? Yes, it would, because the maximum mass is 14.94, and 10 tons does not reach or exceed the maximum. So we could write a safety sign for this bridge saying that the maximum capacity is 10 tons, and we know that if people obey this sign, everything will be okay. Question B, to a whole number of tons. When we round to a whole number, we're talking about rounding to a number with no digits after the decimal place. So rounding to the units position. In the units position, we've got a 4 with a 9 to the right of that. Normal rounding would make us think 5 or higher, and we round up. So I would round that up to 15. But would 15 tons be safe? No, it would not, because the maximum mass that the bridge can support is 14.94 tons. It could not support a mass greater than 14.94. So in this case, although we would correctly round to 15 tons, we would not call that safe or sensible rounding. So we'll have to keep it down at 14 tons. So we could draw a safety sign for the bridge to the nearest whole number of tons and say that a maximum capacity of 14 tons is safe for this bridge. Finally, on to the tenths of a ton. 14.94 has got a 9 in the tenths position with a 4 to the right of that. 4 is less than 5, so I wouldn't even consider rounding that 9 up. Could I have a mass of 14.9 tons on this bridge safely? Yes, that's fine because it doesn't exceed the maximum mass. So we could make a safety sign for the bridge saying that the maximum capacity was 14.9 tons. All three of these masses would be perfectly safe for the bridge. Time for you to get some practice in for yourself. So first let's go through the questions, then pause to work them through, and then we'll take up the answers. First, Mrs. Rogers' roof is 8.724 meters high. She needs to buy a ladder to be able to fix the shingles on her roof. How tall must the ladder be? To the nearest meter, centimeter, and 10 centimeters. So we need to round this value. You may want to first convert it to centimeters to be able to do part B and C. And keep in mind, do we need to round to a value higher than the height of her roof or lower than the height of her roof? Next, question 2. A seamstress needs 248.24 centimeters of lace for a dress that she's making. Let's round this number sensibly to the nearest whole number of centimeters, millimeters, and meters. So in this case, you may want to convert our units of measure to millimeters. Remember, there's 10 millimeters for each centimeter. And to meters, remember there's 100 centimeters in each meter before you do your rounding for parts B and C. And also, think about sensibility. Does the seamstress need more than 248.24 centimeters? Or does she need the length to be less than 248.24 centimeters? So go ahead, hit pause, copy the question, show you're working, and hit play when you're ready to see the answers. I hope you had time to hit pause. Here come your answers. For question 1A, we would round that to 9 meters, higher than the height of the roof. The ladder has got to reach the roof, and it could be longer, but it should not be shorter. B, 8.73 meters or 873 centimeters. Again, that is more than the height of the roof, so we have to round up, even if normally it would not round up. Next to the nearest 10 centimeters, that would be 8.8 meters or 880 centimeters. And once again, even if it wouldn't usually round up, we need the height to be bigger than the height of the roof. Otherwise, the ladder won't reach. Question 2, rounding this to the nearest centimeter, that would be 249. Again, the seamstress needs a certain amount of lace. She could have a bit more and still make the dress, but if she has too little, she won't be able to finish her job. So 249, even though it wouldn't usually round up. B, to the nearest millimeter, 248.3 or 2,483 millimeters. In both cases, again, we've rounded up. Even though we wouldn't usually, we need to have more lace than necessary to be sure that she's going to finish her job. Next to the nearest meter, again, we rounded up 3 meters or 300 centimeters. Here's a few more practice questions for you. Again, I'll talk you through the questions, then you can hit pause and work it out. The answers will come up after. Question 3, the doorway in Andre's basement is only 1.75 centimeters high. Round this value to the nearest tenth of a meter and draw a warning sign he could post so that taller people won't hit their heads. I won't have a problem there. Question 4, an obstacle race includes a swim of 528 meters. Round this distance to the nearest 100 meters and write a warning sign for racers about how to safely prepare for the race. And finally, question 5. A school hall can safely fit 428 people. What is the safe capacity of the hall to the nearest 100 or nearest 10? Again, hit pause, copy the questions, work out your answers, and hit play when you're ready to take them up. I hope you had a chance to hit pause because here come your answers. For question 3, a maximum clearance of 1.7 centimeters would be safe for tall people. For question 4, racers must be able to swim 600 meters. To the nearest 100 meter, you might round that to 500 meters, but if the racer could only swim 500 meters, they would be 28 meters short of reaching the other side. So it's better and safer to round up. Question 5, to the nearest 100, they could safely fit 400 people. We don't want to exceed the maximum safety. And to the nearest 10, we could fit 420 people. Again, keeping the safe capacity below the maximum. I hope that you found this lesson interesting and helpful. I know we're going against our rules about rounding, but we have to take the time to really understand the question to make sure that we're not just blindly following the rules. We are applying math in the real world in a sensible and safe way. If I've left anything at all unclear, please let me know in the comment section down below. Otherwise, play safe, take care, I'll see you soon.